Okay, in this lesson, we're going to be switching gears here somewhat in that we are going to be comparing proportions from two different samples and then see what conclusions we can draw about that. Okay, Connecticut and New York are contiguous states. In other words, they border each other, so they're going to have traffic back and forth across state lines. Both have laws requiring front and rear license plates. A study showed that 239 of 2,049 Connecticut cars were illegal, while 9 of 550 New York cars were illegal. In other words, 9 out of the 550 in Connecticut were not, I'm sorry, 239 out of the 2,049 in Connecticut were not in compliance, where 9 out of 550 New York cars were not in compliance. Okay, so these sample percentages of 11.7 for Connecticut and 1.6 for New York are very different, but are they significantly different? So what we're looking at here is, these are two samples. We think these proportions would apply to the full population of Connecticut and New York car license or car plates, but there's going to be some margin of error from our study to the population. Is this going to be, obviously we see some difference here in these percentages, but is that difference outside the usual that you would expect in margin of error of any kind of a sample? So that's what we're testing. Okay, we are testing to see if these ratios are significantly different, and then we're going to construct a 95% confidence interval estimate of the difference between the two population proportions. So we're just testing to see if they're different. It's going to be a two-tailed test, which we're going to construct the 95% confidence interval to match. So we're looking at an alpha of 0.05, confidence level of 95%. But we need to get started and take down a bunch of information here. So our null hypothesis is going to be that these proportions are equal to each other within the range of margin of error here based on all of this. Our null hypothesis is that they are significantly different. Okay, another way that you could write that is the difference between the two is equal to 0, or the difference between the two is not equal to 0, because there's a huge difference there. Okay, so the two different ways we could write that null and alternative hypothesis. Our confidence level, we talked about 95%, alpha at a 0.05. This is the two-tailed test based on the inequality there. So our critical z-score is going to be plus or minus 1.96. And I want to show you where I could have gotten that from. The activity that we did in class where we were experimenting with all the different alpha and confidence levels with a confidence interval as well as our hypothesis testing. We are doing a two-tailed hypothesis test, so we'll use this center column here. We're looking at 95% confidence level, 0.05 significance level. That means we're going to be looking at this curve here. And so our significant critical values are plus or minus 1.96. Now that's one place you could go, or you can go to our formula page where we've got this chart. Our alpha is 0.05. This is a two-tailed test, so we're in the second row, but we're going to go over to the far column, the two-tailed column. We've got plus or minus 1.96. So either of those places would steer you to the right critical z-score there. Okay, so our next thing is we need to start doing some calculating, but before we get to the test statistic, I want to just take some time to organize all of our calculations. We need to do the p-hat for our first population, and that was looking at the Connecticut numbers. 239 were not in compliance out of 2,049, gave us our decimal value of 0.117, and I could have gotten that from this information up here, but I'm just kind of detailing what our p-hat is. Our q-hat is the complement of that, which would be 0.883. So that another way to look at that is the percentage of Connecticut plates that are in compliance. Okay, so we're looking at the p-hat for p-hat 2 for our New York plates, and we had 9 out of 550. That's how I got that, and our decimal was 0.016. The complement would be the q-hat 2, and that would be 0.984. So another way of looking at that q-hat 2 is that in New York, the plates that are in compliance are about 98.4% or 0.984. So that's getting our p-hat and our q-hats all squared away, whether it was the population or the proportion for the first or the second sample. Then we need to look at our pooled sample, and that is the combination of both data sets. So looking at both states, the sum of those plates that were not in compliance, 239 plus 9, over the total number of sample plates that we're looking at, gave us a pooled p-value, our pooled p-value of 0.094, or pooled proportion I should call it. Our Q bar is going to be the complement of that, 0.9046. So we've got kind of our nuts and bolts here laid out. We can go to our test statistic formula and start plugging that in. Again, this test statistic formula is very different, lots more complicated than the previous one. And again, you would pull that from the formula page. I mean, a quick and easy place to pull that would be from the formula page. Now, when we were looking at one proportion, we were using this formula, much easier to work with. But now we are looking at and comparing two different proportions, and so we are going to be using this formula. We're looking at p-bar, our pooled proportion. I do want to point out the numerator of this is exactly the same as how I presented it in class and in my notes. But this 1 minus p-bar might throw students. And I do want you to recognize that that's just another way of saying q-bar, because q-bar is the complement to p-bar, our pooled proportion. So that might look a little bit different, but is the same value. Okay, back to plugging this all in. So p hat 1 minus p hat 2 would be the 0.117 minus 0.883. That's what we're going to pull in here. Now, our population proportion, we're assuming that both of these are equal to each other. So whatever they are, we don't know what they are, but whatever they are, the difference should be 0. So that's when we plug in 0 here. Notice that you're plugging in, you now have a couple options. You have p hat 1, p hat 2, and now the pooled proportion. Make sure that you grab the correct one. Pooled proportion would come from here, and the Q bar would come from here. So we're plugging both of those in, divide by the first sample size. Our new numerator, plugging both of those in, divide by the second sample size. Now this can get kind of hairy if you're doing this in your calculator. So you want to be really careful about your order of operations and how you enter your information. But plugging this in, we should come out with a test statistic of 7.11, and I think you can know that that is extremely high. It's not even on our Z table. So we know that we are really, really high there. So we come down and look at our three methods. Our critical value method, when we draw the curve, we're putting in our plus and minus critical Z-scores. 7.11 is way over here. We do the p-value here. We can see that our p-value is going to be far less than our 0.05. So both of these would tell us that we're going to reject. We do our confidence interval. I want to point out, and I need to slide this down a tiny bit, when we start plugging in our information to calculate the confidence interval, in the confidence interval, you don't have a speculated population proportion you're dealing with. You're dealing with the p-hats, your sample information. So I'll be plugging in both our population, or our proportion, sample proportion p-hat 1, sample proportion p-hat 2 here. Same z-score. If you remember going back to this activity, this kind of shows you that, you know, we're looking at one and the same curve here when we have a two-tailed hypothesis test. It kind of coincides with the two-tailed event of a confidence interval. So we're using that same curve. So it'd be plus or minus 1.96. Again, we're plugging in the information from our samples. Our first sample information goes here. Our second sample information goes here. And again, that gets kind of hairy when you're doing that on your calculator. And technically, I probably should have put both of these in parentheses here just to keep your sanity there. But we end up with this confidence interval of 0.0828. And for the lower limit, and the upper limit is 0.1178. I do want to make sure that you take the time to interpret this. If we're thinking that these population proportions were the same, that means they could possibly, the difference could possibly be 0. But when we look at our interval here, 0 isn't even in that interval. Both of these values are positive. They're way above 0. So if I draw the number line here, I can kind of see that 0 would be way down here. Our p-hat which the difference of these two samples, the point estimate is 0.1, almost 10%, is dead in the center of those two things. So this all should kind of jive and make sense here. But if 0 isn't included in this interval, then we have to reject the null hypothesis. The difference couldn't possibly be 0. They couldn't possibly be equal to each other. So all three of these methods support the decision to reject the null hypothesis. There is sufficient evidence to support the claim that these proportions are different. Okay, so we'd want to do this on StatCrunch, or I know you guys want to do this on StatCrunch. I'm going to slide this down a little bit so we can see our data as I'm putting it all in. Okay, I'm going to go to Stats. I'm going to go to Proportion Statistics, but this time we're going down to 2 sample with Summary. Okay, so we have a little bit more that we need to put in here. The number of successes, that cars that were not in compliance in our first sample was 239 over a sample size of 2,049, so I need to put that in here. And for our second sample, we have, that was New York, that was 9 over 550. And we go down to our hypothesis test. Again, that's already defaulted for us. And it's pretty sweet here because everything is defaulted according to what we need to look at here. The null hypothesis is that the difference is equal to 0, and we're checking that they're not equal to 0. So I can go ahead and move this up here and click Compute. And I'm really interested in that Z statistic, which was really high, 7.1, 7.11 if I rounded it. And then our p-value was far less than 0.05. So that gave us both of those pieces of information. And from that, whether we're doing the critical value and looking at the test statistic, we know that we can reject. It's in the rejection zone. The p-hat, we know that the p is low. The null must go. But we want to go back and also check out our confidence interval method. So I'm going to go back to options. I've got all my data in there exactly the way I need it. But here I'm going to go down and click the confidence interval, which it happens to be that we're looking at a 95% confidence interval. The default is exactly what we need. So we're going to hit compute, and we end up with that lower limit and upper limit that we'd calculated earlier.